Hi, welcome everyone. My name is Sandra Ahlgrimm and I'm Cloud Developer Advocate working for Java developers at Microsoft. And I'm here with the one and only Bruno Borges. Do you want to introduce yourself, Bruno?
Hi, Sandra. Yeah, thanks for having me. I'm Bruno Borges. I'm a principal PM manager at Microsoft for Java in the developer division. And I am so thrilled to be here because I think this is such a fun topic, and we're gonna build things, break things, and then rebuild them, and it's gonna be fun. Thanks, Sandra, for having me.
Yeah, I can't wait. So today we're going to containerize and deploy a Java app to Azure, and you can follow us along, especially afterwards, under this aka.ms link, or you check out the QR code. Bruno, shall we start with the slides first?
Oh yeah, I am the slide guy. Oh, I'm so sorry. So for people watching, so Sandra will walk us through, and
Mhm.
I will just pretend I know stuff, and I'll just help her with the slides because she doesn't need my help. That's reality. I'm here just for the slides. All right, let's go through this. Um, if you if you need anything, if you want to send questions, hit Brian Benz on Twitter. He is our moderator. He will be helping us on the backstage. Yeah, just talk to Brian. Brian is also works on the Azure Developer Relations team for Java. He works with you, Rosenda, right?
Yeah, we are in the same team. So you can ping him wherever you are. So if you're on Twitch, YouTube, or Learn TV, just ping him in the chat with messages. We are always open for questions. So we can sneak then into the content we're presenting right now.
Excellent. Yeah, so you want to talk about this Learn module, Sandra? So what is a Learn module? How do people access it, and what do they get at the end? I mean, tell us more about it, please.
Oh, sure. So Learn modules, you can find them on docs.microsoft.com. I have mine here open. You can also access this with the link or with the QR code. So, and here I just created a completely new account on this docs page, and you don't have to create an account in order to do this. But what I feel is very nice that it has some kind of gamifications, so there are even levels involved, and you gather experience points if you finish a module. And here, as you can see, I just started one module, the one we are going to present right now. And that's where I got those 400 points from. And it also keeps track how far I've already been. So as you can see here, for the containerize and deploy a Java app to Azure module, I've already checked the introduction. I set up my Azure environment, and I also started with the first two. But no worries, we're gonna completely kick it off again. So Bruno, what do you feel? Why should I containerize my application, my Java app? I mean, I already have the JVM. Isn't that supposed to run everywhere the same?
Uh, yeah, maybe sometimes. But yeah, the thing is, containers are a very easy way to package an application and the runtime and any dependency that that application may need, whether it's a Java dependency or even a native dependency.
Mhm.
Developers have way more control over the environment if they containerize their applications. What base OS am I using? Do I want Debian or Ubuntu, or which version of those distributions I want? I can also have some optimizations specific to my application, and then I can actually tune the JVM of my application much easier if I am containerizing that instead of using a general purpose JVM installed on a server for any application. So containers they do give a lot more control and flexibility to developers, and that's why it's so important for developers to understand and know how to do these things, because once the application is inside a container image, it's so easy to deploy that to the cloud, and that's what we want to show everybody here in this Learn module.
Yeah, and you also can get rid of side effects, right? I remember when we moved to Java 8 at this time, and then I deployed it to our servers, but it wasn't working at all because there was another version installed or used by the JVM, so it wasn't running.
Yeah,
So,
that happens. That happens. Yeah, we got a question on YouTube from
mhm.
AJ. Can we deploy Java applications for free on Azure, or we need to pay for that? As most cloud providers, Azure gives a free tier, so
Mhm.
developers are more than welcome to experiment Azure without having to pay anything. I think you got a certain amount of hours or applications or CPU time. There are a bunch of resources that have a quota for free throughout the year. So every year, if you have an Azure account, you have that quota refreshed. So you can deploy lots of stuff for free, as Sandra is showing here. You want to talk about a little bit of that, Sandra, since you have the dashboard?
Yeah, so if you go on aka.ms/az-free, you can find this page, and there's also what you have with your free account. So you can make use of a virtual machine, for instance, or you go with Azure App Service or a bunch of other services we have right here. And
Yeah.
also the container registry is for free, which is going to be very useful for this section, as well as Azure App Service, as I said.
And I see that you went into a section that it's called always free services.
Oh,
Is
yeah.
that so? So my understanding is that the first section is about the services and the quotas that are free on the first 12 month of an Azure account, but then an Azure account actually have a few services and resources that are always free for as long as the developer has an Azure account. And I think this is what developers will love the most, because it becomes so easy to deploy an application to app service or a serverless function, and quick, easy to study exercises. They can deploy something to the cloud in these two services, but they can also use other services, as you can see in this dashboard. So there's plenty of stuff to do on Azure for free, AJ. So don't be shy. Go on azure.com, get a free account, and start exploring. There's a lot of fun stuff to do.
Yeah, good catch. Thanks for this, Bruno. So I have my personal blog on Azure App Service, and I never paid for it. It's just up and running. So, and you can also play around with functions or other services you can see here.
Excellent.
Okay. So once you have your subscription set up, we can also have a look at the example application we are going to use. So this one can be kind of any Java application, but in this case, we're going to containerize. What's the name again? It was kind of flight radar, right? Yeah. To see some airlines and stuff. And here you can just see a sample Java app, an airlines reservation sample.
I think it's good that we have this example, because COVID restrictions are going down and we can go back up in the air. Finally.
Yeah. At some point.
At some point. We'll get there.
Yay. Okay, so let's come back. So you can read the whole introduction yourself. Just very important. So we're going to containerize this sample application with the Docker file, and then we're going to run the container image locally and test the application. And then we want to push the container image towards the Azure Container Registry. That's private registry you can have. This one is inside the cloud. You're probably already familiar with the Docker Hub registry. That's your place for open source. And then we're going to deploy it to our Azure Kubernetes Service. So that's kind of the whole workflow. And so
it's a Java application that utilizes Maven, right? As a build tool.
As far as I can see, yeah.
Yeah, it's Maven. It's a nice and beautiful XML. Love it.
Yeah. JavaX is back again.
All right, so let's go back to this slide just to understand a little bit of the flow. So we're gonna be containerizing a Java application, and for that, we're gonna build a container image. We're gonna run that image locally just to make sure that it works, and then we're gonna push the image to Azure Container Registry, which is sort of like, for developers, it's like Docker Hub, right? But as an Azure service where I can control which images I publish to my container registry. And there is an interesting thing, Sandra, about Azure Container Registry. Last year, around December, Christmas time, there was this little thing called Log4j, Log4Shell security vulnerability issue. I think most people, Java developers, are aware of that. So the interesting thing about Azure Container Registry is that if you have an image there, we actually have some security tools that will scan those images. And find as much as possible vulnerabilities that your images may have. And I think the security team at Microsoft did add support for scanning Log4j vulnerabilities in Docker images or container images on Azure Container Registry. So I recommend that people do check that out because security is important. And if you have your images in the cloud, make sure they are always secure and have latest version of the most secure versions of everything that your application needs. Okay,
So
so
Bruno,
yeah.
who's in charge what's inside my container? I thought I would just push it on a cloud provider and then now they are in charge to keep it updated.
Well, no, that's the thing, right? Because it's your container image, so it's your thing. The developers have to be conscious about that they are the ones building the container image and just hosting in their cloud environment. So the cloud provider like Azure, we provide the tools and services to help you keep your application secure, but you still need to enable those tools to continually scan your container images. So it's not an intrusive service. I mean, there's a lot of privacy concerns about what is the vendor doing with the contents of my application. So the developer really needs to be proactive and grant those permissions and enable those tools and services so that we can alert them of security issues if they come to happen. So once the application is running, we help manage the infrastructure behind the scenes. And if security is enabled, then we continuously scan and provide those alerts to developers. But everything it's under developers' control for sure.
I see. And as I just created and developed the application, I should also be the expert for this piece of software. So it totally makes sense to me, at least, that I also define and specify my container image.
Exactly. So once the application is packaged, a Docker image, sorry, a container image. I keep saying Docker. I'm just so used to it. Everybody says Docker. It's fine. Docker is not the only solution for containers, but it is one of the main solutions for containers because it basically made containerization mainstream. But once we have the container image on Azure Container Registry, we can deploy that to anywhere, right? What are some of the Azure services that we can run container images?
So I can go with Azure App Services there. So I can just choose Docker there, or I go with Kubernetes, as we said, or I can also use the new, what's it called? Azure Container App Service, which is not
Azure
GA
Con-
yet, but it's in private. I think it's in preview, right? So I
it's
can
in
check
preview.
that
Yep.
out also. But yeah, probably the first step could be app service for production apps. If I just want to show something, I could also use Azure Container Instances, but that's really a thing you would just use for your development.
So my understanding is this: if the developer just wants a single instance of their application running, it's like a web application, and they just want to run like in the same way that they do Docker run on their terminal, but they do in the cloud. Azure Container Instances is a good service because it's a single instance. I'm just testing this out. I just want to run this thing, but in the cloud. So Azure Container Instance allows developers to have an instance of a container image, but it's a single instance. There's no clustering. There's no load balancing. There's no nothing. It's just like a VM, but instead of VM, it's a container. And then there are the more platform services, Azure App Service and Azure Container Apps, as you mentioned. But then there's like the Kubernetes more platform infrastructure, Azure Kubernetes Service. Then
Yeah,
there's
if I
also
really
Azure.
need to scale, right?
Yeah. Then there's also Azure Spring Cloud. What is Azure Spring Cloud? What is it for? What is some of the differences between Azure Spring Cloud and Azure Kubernetes Service? Because I think that is what some customers and developers ask about.
Okay, so Azure Spring Cloud is really made for developers, especially for Spring developers, because I'm not going out of my environment. So I will not even touch a Docker file in my hand because I will make use of the Spring tooling. So I will use build packs for it. And then it's all managed for me. So I know that with AKS, we are calling it a Kubernetes managed service. But then again, all the tools you need, like for logging and security, you have to handle yourself. And also, if you want to do a blue green deployment, you need to do it, or feature releases. You also have to do everything, canary releases. You also have to do everything by yourself. But with Spring Cloud, that's really all managed for you. So you don't even bother with learning how to write a Docker file or how to do a blue-green deployment, because it's already built in, it's already there for you, and it all comes with our partnership with VMware.
Okay, awesome. So it is more like a platform. And for developers that really want to have more control and they want like to hack into Kubernetes and use kubectl, then it's Azure Kubernetes Service, which is the one that we're gonna use for this session. So let's go back here and okay, so we will deploy the container image to Azure Kubernetes Service. So let's walk through a few of the slides. So imagine you're a Java developer, you're building and deploying applications on premises, but now you want to put that in the cloud. So first thing, you need to set up an Azure environment. So let's walk through that in the Learn module and see how developers can configure Azure CLI with their Azure account and get everything ready for deploying things. So let's go. You wanna go through this, please?
Yeah, sure. So to set up your environment, you can either go within your favorite terminal. So I can go within VS Code, or I just use my terminal on my machine. Or I can also go within the portal and use the terminal there. So I don't even have to authenticate with my Azure Resource Manager. So here's my portal. And as you can see here, here's the Cloud Shell. And you can switch between PowerShell and Bash. And if you haven't, you should choose Bash for these exercises. The first time you're opening, it might ask you to create a storage account. That's because I have some history here. And this one is stored in this storage account. So that's why. And don't worry, the storage account, I think, is one of the always free services. So you can totally go with this one. So, and then the module asks you to select an Azure subscription. That only applies if you have multiple Azure subscriptions. Then you need to check if you are in the correct one. Maybe you also have an MSDN subscription. You got that when you have the not VS Code, when you have a Visual Studio license, or you have completed a Microsoft exam. Then you can go on myvisualstudio.com and also enable the free Azure developer subscription that gives you, so like in Germany would be 80 euros every month. I think in the US is 120 US dollars every month, such just to be spent. When the money is gone, all services will shut down and be lost, because it's just for development purposes, nothing for production, but it's also a very nice way. So to select an Azure subscription, you can create a list of all the subscriptions you are having, and then with AZ account set and then -S, your subscription ID, you can make sure that you're in the correct one. I've already done that, so we can go on. And here it wants us to specify some variables so that we don't need to type them anytime again or so many times, because we're going to use these ones more often. And I usually just copy them and go in my notes, and then I would replace them here. Yes, Bruno?
Yeah, so Azure an Azure Resource Group is like a unit of like it's a logical unit where we're gonna associate everything that we're gonna create here, the container registry, the Kubernetes service instance, everything will be put into this resource group. So let's say I want to get rid of everything, and if I just delete this resource group, it deletes all the services that are associated with it, right?
Yeah. So
Okay,
you can totally
awesome.
use this one to bound your resources together. So as Bruno said, to make it very easy for us all to clean up afterwards, as we don't want to spend any money without purpose. Okay, so I copy these ones, and it also asks you to set an AZ location, and I would always go for one of the closest regions, and you can find out which regions are available for you with the AZ account list locations command. So, and here I can see that there are a bunch for me, and as I live in Germany, what you can tell from my strange accent, I will go with Germany North. So, and that are the variables. and then go on. So now it wants me to create a resource group, as Bruno said, just to be sure that we're deploying everything in bound. So now it's saying that Germany North is not available for the resource group. Okay. But at least it says where I can deploy it to. So let's go with West Europe then. Update this in my notes in case we need it later also. Europe. Okay. Okay. Let me just copy paste the commands again. AZ group create in this resource group with this location. Okay, great. So now it should work. I named it Sandra Container Learn, and I'm in West Europe. And it's managed by no one so far. So now I can create an Azure Container Registry. That's our private registry where we store our container images later on. Great. So my pattern is not correct as minus doesn't seem to be allowed. So let's also give it an easier name. So I find it very handy that it gives me all the errors right away, so I can make sure that it will work in the end and I won't be surprised in the very last step. Okay, so now it creates a container registry, and I should also authenticate in order to have access, so in order to pull and push from my private registry. Interesting. So this one is saying that in the Azure Cloud Shell, I'm not allowed. I don't have Docker any longer. So now I don't have a Docker daemon any longer. So I can go with my access token. So this one I probably should save. This one then. Wait. So now I should create a Kubernetes cluster, and we're doing it upfront because it might take up to 10 minutes to be created. Because remember, we have in the background for AKS. What is getting created, Bruno? Do you know that? Can you explain that, why I'm doing it?
Yeah, I mean, first of all, waiting 10 minutes to provision an infrastructure is not that bad. I mean, I used to wait 10 months for a server to arrive in the data center. And we just got used to it. We want everything for like now. So 10 minutes is not too bad, folks. Waiting 10 minutes is enough. You go get a coffee, grab a sandwich, and by the time you're done with your snack, the server is ready to go. Once you provision a Kubernetes instance, that does require reserving VMs in Azure infrastructure. So Kubernetes needs a node pool. A node pool is literally just like a pool of VMs. When you create a Kubernetes service, you can say how many VMs you want on your node pool, and those VMs will be reserved for your Kubernetes service instance. So that process does require, messages will flow around somewhere in Azure infrastructure and saying, okay, I want this type of VM, I want this storage, I want this amount of CPU and RAM. So all of that will take a little bit of time. Plus, there is the setup of Kubernetes itself, the control plane, and all the things that are required to have the environment ready for you to just, one command to deploy an application with containers. So just be patient, 10 minutes. And during those 10 minutes, we're going to be doing other stuff, like building the Java application, which if the application is too complex, you're going to have to download the internet anyways. Maven package will download the internet, just like Node. It's a thing. So let's go through that as well.
Yeah, so let's containerize now our Java application. So here is again the overview. So we have the client. That would be my dev machine where I can run the Docker commands, which would be build, pull, push, and run. And what I really love about these commands is that they're also platform independent. So I can run the same commands, is it on Windows or on Linux, even though I would probably don't use camels. So I would write everything with a small d here. Anyhow, and then there has the Docker host, so where my Docker daemon is running, and this one has the containers and all the images. So and then I can upload my images to my Docker Container Registry, which is the Azure Container Registry we are using right here. And we can also have a look later on how the representation is actually, because it's just I forgot the name. Yeah, we can have a look later on. So here again are the famous Docker commands, or at least the probably most used ones. So you have Docker build to build your container image. You have the Docker pull command, and the Docker run command. So if you have Docker enabled on your machine, you can just go to any terminal and do something real quick, like, whatever we do it. So I just open a terminal like that, a lot bigger, so you can actually see. And then let me check if I have Docker up and running. Oh, that looks not too bad. Cool. So I can do a Docker one and then do the famous Hello World one. So I think my Docker is installed, but it's not up and running. So let's not lose time on this.
Well, I do the same thing. My Docker does not run by default.
Yeah.
I start my computer and Docker is not running by default because it's not every day that I'm gonna use Docker anyways these days.
Yeah, totally. And it's also taking some memory and
Yeah, and then I cannot use Teams at the same time as Docker.
Oh, look at this. So first of all, it gives me a hint that I should check my Log4j 2 vulnerabilities.
Ooh, look at that! Can we see
Not too
that?
bad at all. So that's Docker Desktop, so the one you have to pay for nowadays.
Yeah, some companies have that tool now. Here at Microsoft, we do use Docker Desktop, and it's great because it does help find those security vulnerabilities during development time.
And it's a great piece of software, and I totally understand that our friends from Docker also wants to pay the rents and the bills.
Yeah, but it
So
needs to pay the
here's
bills.
so it
Can we
couldn't
can can
find.
you can you share your screen on the alert that you got, security alerts?
Oh,
I'm curious
totally.
about how that looks like.
Oh, sorry.
If not, that's okay.
Yeah, I can. Sorry for this inconvenience. I will now share my whole screen to make sure that this won't happen again. So here I shared the Docker run hello world command. I just used this one, and then it says that it couldn't connect, so I needed to start my Docker daemon here, and then I could do the Docker run hello world command. And what it does is first it pulls the image from the default repository, which is always Docker Hub, unless you specify differently in your Docker configuration. So you could also bound that to your private registry. Does make sense for some, like if you're running in a secure environment at work, for instance. So, and because it's not locally, it's pulling it from Hello World, so from the library, which is at Docker Hub, and then it downloaded the image. And what's inside the Hello World is that this one. It's just
Okay, it's confirming Docker
training
is
again
up
what it
and
did.
running, and you can run Docker images, build
Yeah,
and run them. Cool.
totally. So I did the Docker pull command, I did the Docker run command, and now I could also push my image towards another registry. So I could also make some changes into the Hello World Docker image, or and then push it to my container registry if I want to.
Okay.
So
let's take a look at the slides. Can you go back to the slides, please?
sure.
Control room. Thank you, control room. Okay, so next up, we're going to containerize the Java application. Now we have an Azure resource group. We have an Azure Kubernetes Service instance being created. And during that creation time, we're going to get a Java application, have a jar file, Maven project, build that, and put into a Docker image. Once we have the Docker image locally, we're going to do a Docker push to the Azure Container Registry that also got created. And then from there, we can deploy a container instance on AKS, Azure Kubernetes Service. Okay, so we're going to containerize that. We're going to do, Sandra, you covered this a little bit about in the documentation, but here's perhaps a bigger view of the flow. We're going to use Docker build. We can use Docker pull and then Docker push and Docker run locally. We're going to do those images all the way to the registry on the cloud. And then from there, we can create containers on Azure Kubernetes Service. Here are the commands. You can, of course, look at the documentation of Docker command. You then can do Docker help on your terminal or check docs.docker.com and find more about the Docker command line. The interesting thing about Azure Kubernetes Registry is that it is a Docker container image registry that works with Docker push. So you don't need to use a special command line to push your image to ACR. But if you do want, actually Azure CLI does have a capability of building the Docker image and hosting the Docker image on ACR already for you. So it's either, right? You can use the Docker CLI or you can use the Azure CLI for that. For developers who are already used to the Docker CLI, I recommend to stick to that. If you really want to reduce the amount of CLIs in your environment, you can just use the Azure CLI for everything. So the next step, okay, let's clone this application locally so we can build that. Is that what you're going to do now, Sandra?
Yes, that's where we are right now. So also the Learn module wants us to clone the repository. You can do it again in your favorite IDE, such as VS Code or IntelliJ, or you stick with the Cloud Shell and do it right here. Okay, so now
what is Cloud Shell? I think we missed that. What is Cloud Shell?
So the Cloud Shell is over here, and it's my terminal within Azure. So I actually have a kind of a repository there.
So it's kind of an ephemeral VM or environment that I can have a shell that is running on Azure Data Center, and so I guess download speed will be super fast in this environment. Is that?
Yeah, that was quite speedy, right? So,
yeah, I mean, I'm sure you can download even the binaries of OpenJDK in just 1 second.
Yeah, maybe it's already installed. Okay, let's take this challenge to the end, Bruno, because just to make sure we're doing the Learn module first, but then let's keep that totally, and let's not forget about it also. So it's a bit weird that it wants me first to go. Okay, so now I'm in the airlines folders, and I should have the POM XML here. Cool, so I can run the Maven commands. Yeah, and Maven is even installed on this Cloud Shell thing. That's nice. So I can run it up here. And let's see what's next. Okay, so hopefully it will be successful. And then we're going to construct the Docker file. And here for this one, it's running on Apache Tomcat. So obviously, first of all, we need a kernel, but that's on the Azure side. And then we need our image layers and some kind of Java runtime. So at least we will need a JRE for this. And then we can have our Apache Tomcat running on it with our application code.
Okay.
Mm-hmm. So let's see first. So the build is successful. That's cool. So the easiest way to containerize would be to do exactly what we did with the maven run command to start the application inside the container. But this one, as it's already introducing, multi-stage builds, it even wants us to follow more of best practices. So with, let me think, I think it was version 117 where they introduced multi-stage builds, and here you can even do as many stages as you want. You can do a build stage, a test stage, and a runtime stage, and it makes totally sense if you think about it. So now on this machine, I need to have Maven installed in order to run it, and probably also for my build stage, as we're using Maven as the build tool, Maven needs to be there. But in order to run my Java application, all I need is the JRE and my jar file. So Maven doesn't have to be installed on my development machines or on the deployment machines. So that's a cool thing and a cool way to keep my latest image very, or at least smaller than having my build tools integrated and also maybe my testing tools.
Right.
So that's what we're introducing here.
So instead of running Maven MVN package in your environment, you're gonna actually run that during the flow that builds the Docker image itself. So okay, I see Maven clean package.
Yeah. So here it packages my WAR file in this case, and then I can only make use of an JRE slim version in order to run the var file with this shell command here. Okay.
So there is a Tomcat image already published, probably from maintainers or the community that maintains community-driven Docker files that are built and then published. So here we got Tomcat version 8.5.72 that comes already with OpenJDK, and then we're gonna change a few settings here with XML, and then copy from the build stage, which is the previous block, and that's how you define the name, from image as build. So
it could be also as Sandra, and then you have Sandra here again.
Right. And then you can access the file system of that stage. That's build target war. And then you're going to copy whatever war file is there into the web apps folder inside Tomcat. That's a lot simpler than building outside the Docker image and then copying files into the Docker image. Because now I can just check out the source code and do Docker build. And everything gets created as a Docker image. The Maven is there, download, OpenJDK is there. I don't have to have OpenJDK installed. I don't have to have Maven. All of that happens inside the OpenJDK image. That's the Docker file. Excellent.
Okay. So I just copied this one with VI. Obviously, you can totally do that also within VS Code or any other IDE to have also Dockerfile support to create those images. And Bruno, we shouldn't forget to talk about these base images later on, especially when it comes to production environments. Okay?
Yeah, absolutely. Let's build this and see how it goes. I think we covered.
I think you already explained, right, the Docker commands. So at least you always have a from statement. That's a from, and I think the cmd or the run command also needs to be there, and that's all. So that's the minimum Docker file. So you always have to have the base image. I totally forgot what was the smallest one. So, and then here it also explains you very much in detail what Bruno also told you, so you can read it through afterwards and do it yourself again. And also, again, the Docker documentation is very well descriptive and very nice to read, actually. So now, as Bruno suggested, we can actually build the image. You can build it without the tag, then Docker will find a funny name for it, or your Docker daemon will find a funny name for it, or you specify one. So let's see if that runs also in the Cloud Shell, even though I don't have a Docker daemon here. Oh, okay. Bruno, shall I try to install it? Or otherwise I will go and switch locally.
I wonder. I've had this experience before. I don't think Azure Cloud Shell still supports Docker inside of it. It does come with the Docker CLI installed, and only a few commands are available. But I think we're gonna have to rely on your local computer to make this work.
Okay, so I will quickly redo the things on my local machine, and you can maybe go again in the slides and explain the form statements better, and maybe also what base image to be used.
Yeah, let's walk through that. So now we are talking about building and run a container image from the Java app. So we are ultimately do a Docker build command, which requires local an environment with Docker installed and running as a service. So you don't need just Docker CLI. You actually need a Docker daemon or the Docker background application up and running. And once that happens, you have a build. You can actually do Docker run and specify a port. So here we do -P8080, and then we also match that with port 8080. So it's matching the port inside the container with the port in my local computer, and then the name of the image that I want to run. So if you're familiar with Tomcat, port 8080 is the default HTTP port. And once it's up and running, you can access localhost port 8080 / the name of your application, which usually is the name of the WAR file without the file extension. And this is the log. You may not be able to see very well, but this is the log of the application or Tomcat starting and showing that the application is up and running and is accepting requests. So now all you need to do is go to the browser and hit port 8080. So I want to just go back a little bit and talk about this that Sandra was covering on the documentation of the Learn module. So Docker works with several layers of file systems. So once you have your base image, that base image already has at least one layer of file system that brings lots of files that your application may require, such as some base OS tools or some libraries like OpenSSL that may be required for establishing secure connections. On top of that layer, you can have a layer that may be, for example, the Tomcat layer. In this case here, we see Java runtime and then Tomcat, Apache Tomcat layer. These two layers may as well be combined as a single one, or maybe the Tomcat image is building on top of an OpenJDK image, and then you see different layers. But ultimately, you're going to have your layer, which is a consequence of your Docker file, and that layer will have your application. And that is where your application will run and have its own file system and do the things that you need. And to accomplish that, there are lots of commands. So the from command that Sandra was talking about, here's my base image, with the work there, what I want to set, where the user is in this environment is sitting. So if I run a cd command, or if I run an Maven package, that's the folder where the command will run. And I can use the copy, add, expose. There's a bunch of commands that are in the documentation that goes into the Docker file to help you build your Docker image. And the most important thing is for each command that you put in the Docker file, actually there will be a layer, a file system layer created out of that. So if you want to optimize your Docker file, you should reduce as much as possible the amount of Docker file commands or instructions in your code. So that will give you less layers and ultimately make the Docker image smaller at the end. There is a command to run that will remove all layers and make a single layer. So that can also help reduce the size later on. So once your application is ready to go to production, you may want to do that. Okay, so Sandra,
So I built the image.
you've built the image. Okay, let's take a look at that.
Yeah. So I now built it here. As you can see, it's also better if you have the IDE because now you can actually see, you have some syntax highlighting and so on and so forth. So here's my Docker file. I built and tagged it, and now I can check if my image is here with Docker image ls. And as I've used the hello world before, that's also here. And here's also the size of my image. So I could also make some tricks to make this even smaller or bigger, whatever I need. So, and now, yeah, I see that. And now I can also run my image with the docker run command, and I will pass the ports so that from inside the container to the outside world, because otherwise I won't be able to access this.
That's the beauty here, right? We didn't have to download JDK, Tomcat, or anything like that. I mean, technically, even Maven we don't have to have installed locally because it's downloading and building as part of the build flow of the Docker image. That's excellent.
Yeah, especially if you work with different technologies all the ways, and you really don't want to mess up with your local machine, so you can totally not do it. Okay, so I get a 404 not found for my local host. So let's go back to the documentation. Maybe I missed to give a parameter or something like this. So here, startup. Oh yeah, there we go. Need to give it this one also. So here are my airlines. Okay. And I can log in. Maybe make it a bit bigger. Okay.
I like it's an airline company website, but it suggests that you can travel to the galaxy. So, funny.
Yeah. Always reach higher, right?
Above and beyond.
Yeah. Okay, so now I can. Oh, I can even log in. So
Oh yeah, because this demo application actually comes with a custom configuration for Tomcat, which may include some custom username and password.
Let's check if that's already working.
I think the password is password.
Yeah, let's see.
This is not a best practice, by the way. Let's just be clear.
It doesn't like it.
It doesn't work. Now, the focus of this demo is to show that the application is up and running, not on fixing bugs in the application, right? so we can move past that. So now we have the application built and running. So the application works on port 8080. So now what we need to do, we need to push this image from our local Docker images repository into the Azure Container Registry. Is that true?
Yeah. So that's why I have these. So it's resource group, registry, Kubernetes cluster, location, and the DNS prefix. So that's why I have them in my notes also, because now I think I will stick with VS Code terminal. So let's stop this. Give them the parameters and the variables as well. So let's see if I can log in here.
So while you do that, we got a question from YouTube. Can you point to best practices for login From Java to Docker to Azure. Um, okay, so the question was from Ray Power. Ray, that's a good question and very, very on time with the Log4j issue. Um, Best practice is, regardless of Docker, actually, if you have a logging framework configured for your application, like Log4j or Logback or SLF4j, or Log4j1, Log4j2, it really doesn't matter. You can also actually even not use a logging framework, third-party library, external library. The JDK, the Java platform, does come with a Java logging API. You can use that. It's called JOL, or Java Util Logging, and it's great. It works just fine. So best practice is really like, hey, where do you output the message to? Are you putting that into a log file? Are you sending that to an endpoint that will put that into so like a logging service, so you can read that in a more central way. So there are a few solutions when it comes to logging that you can actually configure your application, the logging library, instead of outputting to the console or outputting to a file. It will actually output to a cloud service, where you can then go to the cloud dashboard and do logging analysis or parsing log analysis. And the interesting thing about that, and it's why it's better, is because when you containerize an application, you actually expect the file system of that instance of the container to be ephemeral. So it won't persist anything. The container may die and you won't have access to those log files. So you have to think about that. Some developers prefer to attach a storage disk to container instances so they can push those files to those storage disks and access those files later. That's fine. That's also a solution. But then you still have to manually process all those files and parse all those files and try to identify. Now imagine you have like 500 instances of containers across 20 different applications. How do you manage that? So that's why, if you really want to get the best value of running container applications in the cloud and do better logging so you can find issues when they happen, use a logging service that you will take those logging messages and host them for you in a more centralized way. And those solutions allow you to parse, query, search, get notifications of messages that happen in the login, and have like a, oh, I want to keep only the last 30 days of logging or the last 3 months of logging. I don't want to host like 30 years of logging. You have all those options. So that would be like my recommendation, my suggestion. Think about how you will access logging files or logging messages if you need to, and how long you want those things to remain available to you. So answering those questions will help you find the best solution for you.
Okay, coming back to our example, I logged in. I just had to specify the container name, the registry name. And as we already specified this in an environment variable, I just put it here. And then if I want to push something to another registry, which is not the default, so which is not Docker Hub by default, I need to tag it first with the name of my container registry up front. So I always have my container registry name, and as we're running in Azure Container Registry, it's .azurecontainerregistry.io, so .azurecr.io, and then how I want to call this container or this image of my container. So, and then I can push it, and because I have the name specified, it will totally find the correct container registry. And also, to be allowed to push it, that's why I had to log in first. So, and now it's pushing the different types of layers. And as you can see, I have a bunch of layers. So maybe we can speak about the best practices also later on again. And if I want to know the metadata of this image, I can show this with this command. So here you can see I see the create time. I can also see the digest. So whenever I try to pull the newest image, so if I don't specify a tag or version number, it will always go for latest. So, and that should always be the newest one, and it checks, or the latest should be the newest stable one. And if there are any changes, it will always just go into the digest and changes if this hash value is different from the one it already has on the machine. Okay. So that's what we have here. So now we're actually ready for our deployments to, for instance, Azure Kubernetes Service. And in order to do a deployment on Kubernetes Service, we need to have the deployment YAML. So up and defined, and then we can publish this application there. So let's see. Bruno, do you want to talk a bit about pods and replica sets while I create the deployment YAML?
Yeah, let's. I don't think I have this the YAML file on the slides. So let me access. I'm gonna access the learn module, and then we share my screen.
Okay, it doesn't. So I just thought in general, but anyhow. So I think you mentioned already that we're having pods, which is basically VMs or some kind of virtualization machines where our OS is running on, and then we have not really a Docker daemon these days, but some kind of Docker runtime installed so that we can at least start our containers.
Right.
Let's just right quit. So, and here in this case, we want to have one replica of our flight booking system sample. And this is the container names, and it can find it here. And we want to have one CPU and 1 gig of memory at least. And we also limit it to 2 CPUs and 2 gigabyte of memories. And we're opening the container port 8080.
So this is where we may want to talk a little bit about some research that we've been doing recently. Now, this learn module is great for people to start from, but when we think about okay, like real application, production application, we actually recommend developers to have the requests equal limits. So if the limits are 2 CPUs, 2 gigs of memory, we suggest that developers should put 2 CPUs and 2 memories for request as well. And we actually recommend developers to do 2 CPUs for Java application because the Java runtime or the JVM is actually a multi-threaded engine or runtime. It has a garbage collector. It needs multi-threads to perform and behave well. So there isn't much of a point in running a Java application on a single processor machine. Now, even though that's not how Kubernetes actually works, when we talk about requests and limits on Kubernetes, we are actually talking about quota time or limits in time access to the processors. So an application with multi-threads can actually run with multiple threads at the same time, even if you say one CPU in this deployment file. What one CPU actually means is that these applications will be allowed to run for the amount of time of one CPU cycle, even if the application has multiple threads. Now, in practical terms, let's imagine that you have a multi-threaded application and you store 2 threads, and then both threads run in parallel at the same time. Now, the moment that each thread consumes, let's imagine here CPU cycle is 1 second. Now let's imagine that each thread runs for half a second, but you ran both threads at the same time. Now your application has consumed all the amount of time within half a second because it consumed 1 second but split into 2 threads. So that is how Kubernetes scheduling and throttling works. And your application may have some performance issues and impacts if you don't be careful enough with how much resources you're giving to your application. So watch out for that. It's not that simple, and that's why some developers may actually prefer some other services like container apps or Azure Spring Cloud or App Service, because you don't have to deal with Azure deployment files, especially because it's YAML, and YAML comes with other problems. So there's a lot to think about here. If you can, don't use that, but if you need to, this is how it's done.
So the real issue is that it's in the YAML format here.
No, of course it is. Of course.
Okay, so it says we have it. We deployed it into our existing Kubernetes cluster, and it seems to be ready. It's up to date, available since 11 seconds. Oh wow! So
now we have these concepts. We have Kubernetes cluster running, and then within Kubernetes cluster we have a node pool or VMs. On each node, I can run multiple pods. On each pod, I can run multiple containers. And it is the container that I will set the amount of CPU and memory limits or requests that I want to allow for my application. So if you're let's say you have a pod in a deployment file like this with, let's say, 5 containers, and each container you're asking for 5 CPUs, Kubernetes will schedule an instance of that pod on a VM that it can run because it has 5 cores available. So Kubernetes will schedule that pod creation to a node in your node pool where it can run, because you're saying you say if you need 5 CPUs, Kubernetes can only run that in a node that has 5 CPUs. It is an interesting topic, and sure, we can talk about that. I really want to see where we go with this. So if we can see the application up and running, and then we can go back and discuss about performance and pods and node pools and all that good stuff.
So shall we first look at the app up and running, and then we check the logs?
Yeah, let's see that.
I think we can go a bit off script here. So let's check if it's actually up and running. So it was 8080 and then flight booking system sample. There we go.
Oh, look at that. Beautiful. So how do we
to write it? You can also access my AKS cluster now.
Oh yeah, it's true. Anybody can go there. So how can we go back to the deployment file just to take a look at it and understand? Sure. Because Kubernetes is a cluster, right? So you can have multiple nodes, and within nodes you have multiple pods. How do we tell that this URL will hit that pod?
So first we said that's our deployment. It's got the name flight booking sample. And then here we have our container we want to have up and running. We give it the port 8080. And then what makes it available to the outside world is probably the load balancer here, which maps it here to the app up and running, the flight booking system sample. And then I also need to give it again the port to be put to the outside.
Okay, so I could actually expose this publicly on port 80 if I wanted, right?
Yes.
Okay, cool. So and this is the load balancer configuration. So now now let's say the performance of my application is not great, and I feel like I want my application to go faster because I'm getting too many users. My flight booking system is the best because it's the only one that can book a flight to the galaxy. So everybody wants to get on a spaceship. How do I increase the number of replicas? And I just want to scale my application now. How do I do that?
So I think I can do it here, right? So I go with replicas, and then I can give it any other number. So like 2 or 3.
So let's give 2.
Okay. And let's redeploy. There you go. So I apply my deployment YAML again. and it found out that the service is unchanged, but my deployment got configured. So now if I check it all, I should be able to see that now I have 2 desired and 2 current, but only 1 is ready so far.
Got it. So it's starting the other pod instance. Okay. Now this is a tricky part because developers think, my application, if there is a performance issue, all I'm going to do is just increase the number of replicas. And that's the interesting part, Sandra, because we've been playing with this, and we've learned that just scaling out an application is not the best solution for addressing performance issues. Now, with Kubernetes, it is super easy to fix the topology of an application when it's running. If you want to scale out, or if you want to scale up, you can just go to this beautiful YAML file and just make some changes. So if you want to give more CPU and more memory, you can just change that. So how about we give 2 cores, make sure that we have 2 cores on this application.
Okay. 2 cores at least, right? To follow the best practices you just introduced us to.
Yeah.
So I also want to go with 2 CPUs then, right?
Yes. 2 CPUs and 2 gigabytes of RAM.
Cool. So I go with this. Oops. No, I'm not in the correct space. Okay. So I can apply my deployment again. And let's see if that works.
Okay, so now that's interesting. So we see in a way we see 3 here, but the reason is probably because Kubernetes is scheduling new pods with more CPU and memory, but keeping those old ones is still up and running, so the application doesn't look offline.
So, okay. What's next in the Learn module? So we now can actually access the logs from the pod. So, and then we can see something similar, like you can see it here in the Learn module also. So, and what we can also do is use the external IP to access the running app. That's what we have already done. So, and last but not least, the knowledge check. So that's where it becomes very interesting, right? So I think we can do it within the slides.
It's a little gaming. All right, let's test the knowledge.
So everyone can totally do it with us.
Yeah. So for those who are watching, let's go to aka.ms/polls and vote for question 1. Which tool allows developers to write instructions that are used to build container images? Is it Maven build tool? Is it Docker Runtime, or is it Azure Container Registry? How much time do we usually give people, Sandra? 7 seconds?
Yeah, we should wait just a little. That's actually quite tricky questions. That's a tricky question.
Yeah, it's a tricky question. It has like half right answers, half wrong answers.
Yeah.
All right, so the best answer to this one is Docker Runtime. Now, I wouldn't say it's Docker Runtime. I would say it's the Docker CLI or the Docker command or Docker desktop or whatever it is installed. Docker Runtime is something that is part of that entire platform, right? A little bit weird question.
Yeah.
So let's go to the next question. Which service allows you to build, store, and manage container images and artifacts in a private registry? Is it the Maven build tool, the Docker Runtime, or the Azure Container Registry? I think this question is too difficult, Sandra. I think this one, people will have a hard time getting it right.
I think we said that multiple times, and I'm also confused that they put Maven build tool and not Nexus here?
Yeah, I mean, think about all the other options that would play well in this category. We are making it too easy for people. That is the reality. We want people to get it right. Not we don't want to trick people, right? Just want them to get the right answer. 100% performance.
You know, if you have 100 performance, you get double points on the experience here. So instead of 200, you actually get 400. So that's also part of the
It just
game. So don't do them too quickly.
So the right answer is Azure Container Registry, probably because it contains the word registry in the name. So I think that gave away the answer. Okay, this one is actually really good. I like this question. Which one is not a Docker file instruction? Now, this is tricky because we didn't walk you through the entire Docker file documentation. So we didn't show you the exhaustive list of all of the commands and instructions that you can use in a Docker file. So unless you already know the answer, you're gonna have to take a guess here. You really will have to. Now, there is a good guess, but think about the commands that you did see in this learn module. That should give you a good guess. So I will count to 5, and then we'll go see the answer. 1, 2, 3, 4, 5. And the answer is start. Start is the right answer, or actually the wrong command. However we want to interpret this question. Next question is, what is a multi-stage Docker build? Now, Sandra talked a lot about this one. If you missed it, you're going to have to rewind, watch it again, and then come back to the recording of this puzzle and then answer that on demand. So what is a multi-stage Docker build? A feature that enables you to create a smaller container image with better caching and a smaller security footprint. Or B, a feature that enables you to create larger container images that use less caching. It's tricky. I don't know the right answer for this. I'm confused,
all votes are
Sandra.
for A so far, I saw.
I'm confused about this one.
I'm very happy that you listened that carefully. Thank you all for voting correctly.
I will have to go back and watch it again. That's just reality. Okay, so the right answer is A, a feature that enables you to create a smaller container image with better caching and a smaller security footprint. And that is because, you put everything in the Docker file. So there's no way of getting, files injected or overridden or whatever. It builds from there. So reproducibility is actually a key element of increased security in build pipelines. You want to be able to reproduce the build of your application no matter when, where, or how. You just want to run one command like Docker build, and you get the same exact binary of your application code. All right, so we did get some folks got it right. Some got it wrong. I think everybody got it right on the last question. Almost everybody got it right on the second last question. And the other questions were indeed a little bit confused. But that was part of the game. That was fun. So that means that if you're still confused, go check the documentation and get unconfused. Make sure that you get unconfused out of this. It's important, and that's why documentation is important. So keep it reading. We got one other question here. Bruno, I wish the Java community in Microsoft to grow bigger and stronger. What are the opportunities out there to engage and contribute? Thank you, Zahid. That's a great question. I would say if you want to engage and contribute with the Java at Microsoft community, follow us on Twitter. That's for start, Java at Microsoft. You can also take a look at all of the Learn modules for Java on Azure and development with Visual Studio Code and GitHub. Those things developers are already in love with. We saw here Sandra using Visual Studio Code. Java support comes from a partnership between Microsoft and Red Hat. GitHub has great support for Java as well, so make sure you use that. And yeah, once you have everything coded in Visual Studio Code and built with collaboration through GitHub, all you need now is deployment. Consider Azure. It's a great platform. We work hard every day here to make sure that Java developers get a very idiomatic and native environment and experience with Java applications across Azure services. So please do that. And also, we have a Java blog, devblogs.microsoft.com/Java. And yeah, thank you for the question and thank you for engaging and sticking with us so far. Appreciate it.
So I got 400 XP on the check, on the knowledge check. But I've maybe I did the module now the third time or fourth time, so maybe that's why.
I think you cheated. I think you cheated. I think you did this for the second time. Something tells me.
So now I can check and I can see my summary here, and I can also clean up the resource groups. So please don't miss to do this command as well. Bruno, I have one question. As we just talked about the Java community inside Microsoft, I heard something about the Microsoft build of OpenJDK. Can you tell me something about it? And I think there's also a container image for it, isn't it?
Yeah, there is. Yeah, Microsoft, we do have a build of OpenJDK. You can go to microsoft.com/OpenJDK. And from there, yeah, maybe Sandra, you can go there on your browser while you
I think it's on the last slide, so you can just share this.
Oh, can I just share the slide? Okay, let me take a look at that.
I think we created an AKA-MS link for this also. Oh, that was too fast. One before. Oh,
this one. Oh, yeah. Okay, so okay, yeah. So you can get a summary of everything that we talked about on the first link, and on the second link, Microsoft build of OpenJDK is a binary of the OpenJDK project, which is the Java technology, the Java platform with the Java API, the JVM, and the development tools. And we produce that for our internal use and also for our customers on Azure. So if you're an Azure customer and you're running Java applications, you can use our build of OpenJDK for free. You get support. And we also have container images that can be used very easily. And they're very easy to customize as well. And we have plenty of documentation on that. How to build our, how to use our JDK on the images that we provide, but also how you can hook your own images and use your own Docker files with our JDK. Very easy. And some services on Azure are about to get updated and get the latest JDK 17 with the Microsoft build of OpenJDK. So very soon, by the next quarter or so, you will be able to run Java 17 applications on managed services like Azure App Service and potentially Azure Functions and Azure Spring Cloud. You can already run Java 17 across Azure services where you have the control over the environment. So build your own Docker image like we did here today with Java 17, get productive from day one, and deploy on Azure. So just have fun with that. We did get a question on the chat. Can we deploy Java Android app on Azure? That is a great, slightly weird question, but great question. Ruta,
do you want to put the APK on Azure so I can download it from my mobile phone then?
Yeah, I think hosting files for internet download, definitely you can do that on Azure. Running an Android application on Azure is a little bit weird because Azure is not a phone. So that would be weird. But there are some technologies that actually allow developers to write Java applications that can run anywhere. So there is this technology called JavaFX. So you can write your visual Java application. JavaFX is a platform for writing graphical applications. And it allows you to run that graphical application as a web application in your browser through HTML5. Or you can even run that application on Android or iPhone. So, or even as a desktop application on your computer. So it's a great piece of technology. So in a way, we could argue that yes, you may be able to run a Java Android application if you write it with JavaFX and host it as a web application on Azure, so it can be accessed from anywhere. So there's lots of possibilities, and yeah, developers are welcome to be creative and try lots of things.
Yeah, if you're looking for an emulator, I'm not sure if we have something like this. So you would probably stick with within your Android Studio or within your Xamarin. Or now it's inside Visual Studio, right? So
yeah,
then you
we
can
do
stay
have.
there.
There is a service. There is an Azure service or a Microsoft service. I'm not sure if it's Azure specific, but there is a Microsoft service that allows developers to build and test mobile applications on multiple devices across Android ecosystem, and I think also iPhone. Where you upload your application to us, and we run that application on several devices, so you can test your application. But that is conversation for another topic: mobile development and how cloud services can help you with that. So, if you want to go back to this Learn module, visit this URL: learnlive-2022-0321b. That will take you to the beginning of the Containerize and Deploy a Java App to Azure. We used Azure CLI, Visual Studio Code, Docker. We used Azure Container Registry, Azure Kubernetes Service, and all of that, so you can have from a Java web application running locally with Tomcat to the cloud with scalability on demand. Now, last thing, don't miss on next week how to deploy a Spring microservice to Azure. We're going to have, I think this one is from your colleagues as well, Sandra. Is it Mark Hacker who is presenting this?
Yeah, so I think Julian is going to present this, and Rory wrote the module. So, oh no, it's the Spring microservices. So this one is on Azure Spring Cloud, and this one Julian Dubois created. So I think we talked a little bit about Azure Spring Cloud and how it's different from AKS already. So from our Kubernetes service.
Right.
So, but within this Learn module, you even become an expert. So make sure to check in next week, Monday.
Excellent. Excellent. So people got, today they learn about KKS. Next week they learn about Azure Spring Cloud, and they just keep learning and learning and getting those XP points, right? Which they can convert later on for tweets. I don't know. It's an interesting score. People have get track on that, so you can tell your friends, hey, you got high numbers, especially your coworkers. You know how to do it already. Tell your manager, I know how to do this thing. Just show them the dashboard. That's a great resource. Thank you.
Thanks, everyone. Bye.
All right. Thank you, everyone, for staying with us, and have a good day. Take care now. Bye.